Welcome back to the Savage Sullivan Math website. Today we're going to continue our work with exponent laws, but we're going to look at expressions or problems that combine more than one law within a problem. So when we look at this problem, I have p to the fourth times p squared. All of that is in parentheses being raised to the fifth power. So we have a couple different ways we can approach simplifying this problem, but just because I like to follow order of operations and because it's a good habit to do, we're going to work inside of those parentheses first. What's nice about this problem is that the bases are the same. Both of the bases are p. So I can use the product of powers property that says when we multiply things that have the same base, we can add the exponents. So here, inside of my parentheses, p to the fourth times p squared, we know is going to be p to the sixth power. Because again, when the bases are the same and we multiply, we can add the exponents. So now we have something like this, p to the sixth power being raised to the fifth power. So now we can apply the power to a power property, which says when you have a power being raised to another power, we can multiply the exponents together. So here, my final step would be p to the 30th, which is, again, 6 times 5. Since I have nothing else here, I'm going to circle that, and that must be my final answer. Nice!
Wicked work, Mrs. Savage. Here we have another one where you see a couple of different exponent laws being displayed. So here, the difference between the problem Mrs. Savage just did and the one that I'm going to do here is I don't have any variables. All I see are numbers. But I do have a couple of bases. I have a base of -3 right here, and I have another base of -3 right there. So I could maybe assume that I could combine those. One thing that I need to remember is how many of these -3's do I have? What is the exponent with this base? The exponent with this base is a 1. That's really important to remember. If you don't see one, there is an assumed 1 there. So I'm going to follow the same rule that Mrs. Savage did, and I'm going to put the like bases together by following the product of exponents rule. So if like bases are being multiplied together, all you have to do is add the exponents. So my like base is the -3, and I have to add the exponents of 1 and 6. So 1 plus 6 is a 7. Now this is all still within the bracket right here, and outside of the bracket you have the exponent of 2. So now I'm done with the product of exponent rule, but now I need to do the powers to the power rule. So I have one base of -3 being raised to the 7th power, being raised again to the 2nd power. And remember, when you have powers of a power, one base that has a lot of exponents, all you have to do is multiply those exponents. So our final answer will have a base of -3, and it's going to have the exponent of 7 times 2, or 14. Don't forget that you have to have the -3 in parentheses. If you drop the parentheses, that's assuming that just the 3 is being raised to the 14th power. But it's actually the -3 that's being raised to the 14th power, which is why you have to maintain the parentheses. So this is your final answer. If you found this video helpful, please like and subscribe.